Hi there, my name is Teddy Rose, and today we'll be talking about the application of Amperes Law. So basically what Amperes Law is a way to relate the magnetic field and current. And so basically how we would do that using his equation Ampere created would basically be the integral of the magnetic field vector dotted with the change in length of any surface, really. So anything that has a magnetic field running through it. And then basically, this is going to be equal to, this would be equal to an object that would pierce through this surface with the magnetic field. It would be equal to the current running through this object, which is piercing, times mu naught. So basically, we're going to use this law right here to determine the unknown current, to determine an unknown current I, given some magnetic field B. So here we have the example of a circular object that is open with a radius of 0.5 meters, and it has a constant magnetic field throughout it that is equal to 3 Teslas. And then we have a wire, and then the magnetic field is basically going in this direction. And then we have a wire running through it this way, or we have a wire that just goes through it, and then the current is going through it this way. So we want to find what the current running through it is based upon a magnetic field oriented in this direction with the radius of that on the object. So basically, since we know that the magnetic field is going to be constant throughout this circular loop, and we know that the length, or basically if we were to unattach the circle and stretch it out, we know this length is always going to be constant. It's never going to change. So we can know that it's going to be B times L since it's constant, which is equal to what we had up here, mu naught I enclosed. So basically, we can figure L out by determining the circumference, 2 pi r, which then is simplified down to, since we have the radius, 0.5 meters, just 1 pi, or just pi meters. So then we get to plugging that in, multiplied by the magnetic field, which is 3 Teslas, which then is equal to mu naught negative I enclosed. And we can determine this by using the right-hand rule. So basically, we're going to have our magnetic field curling in this direction. So we're going to have a positive current would be running through this way. But since we have a current running through this way, it's going to oppose that, what we would think is the positive current, because of the curling magnetic field this way, since we oriented it this way. So it's going to be negative. So basically we plug it through, and it's basically a plug and chug, solving for I enclosed. And then we know what mu naught is, based upon previous knowledge that mu naught over 4 pi is 1 times 10 to the negative 7th. So therefore mu naught is 4 pi times 10 to the negative 7th. Fall all the way down, and we get that the current running through is negative 7.5 mega amps.